If x equals 10, then 2x to the power of 3 plus 0x squared plus 0x plus 3 equals. Well, this and this are 0, so really all we have is this 2x to the power of 3 plus 3. And that x is 10, so that's pretty much all that is. So that's going to be 2003. And therefore that would be D. Each of the following is a factor of. Okay, so we're going to factor this, and that factors into x, 4, 1, positive, negative. Okay, so x plus 4 is a factor. So they're looking for the one that's not. So that is a factor. That is a factor. And 1 is always a factor. So I guess the one that's not is the x minus 4. If n times 2003 is equal to 2003 plus all of these guys, then n is, okay. So if I were to rewrite this equation, it would be equal to 5 times 2003. And then if you remove the 2003 from both sides, you'll get n equals 5. So number 3, the answer is A. Least value of x for which 2 over x is an integer. Okay, so let's do all of them. So this one, I'm going to plug all of them into that. So that would make it -1. If you plug 2, it becomes 1. If you plug -1, it becomes -2. And if you plug in 1, it becomes 2. So let's read this again. The least value of x for which 2 over x is an integer. Well, they're all integers. So the least value was A. Because A is -2, and that's the smallest one of all the answer choices. Okay. When a party hat, when unfolded, is a square, when the area of the square is divided by a perimeter, the quotient is 4. How long is a side of the square? Okay. So here's a square. The area, let's just call it x as the side length. So they're saying when you have the area, so the area is x squared, and it's divided by the perimeter. Well, the perimeter looks like 4x. That is equal to 4. Okay, so we'll solve this. This becomes x over 4 is 4. So x is equal to 16. How long is the side of the square? Well, there we go. The side of the square is 16, and therefore number 5, that would be C. X plus 1 minus x minus 1 plus 2 plus x minus, okay, so all that stuff. So x plus 1, let's take it out of the bracket, so we minus x plus 1 plus 2 plus x minus 2 plus x is equal to, okay, so let's add all these. This disappears with that. This disappears with that. And then we have this and that, that's 2x, and that, so plus 2. 2x plus 2 is what I get, and that is B. The number of even integers between 1 and 2003 is the same as the number of odd integers between 4 and... All right, well, from 1 to 2003, the number of even integers are like 2, 4, ... all the way till 2002, right? So how many of those guys? I think it's 2002 divided by 2. So there's 1001 even integers between 1 and 2003. So we want the same number, but this time we want them as odd integers between 4 and something. Okay, so the odd integers would be of the form 5, 7, 9, ... all the way till something. And we want 1001 of them. Okay, so how do I do that? Well, we didn't include 1 and 3, right? Because that's outside of our range. But if we did, and we wanted 1001, just double it, so 2002. Yeah, so you'd have to go up to at least 2003. And that would give you... well, from the very beginning, you'd just add 1 and divide by 2. So 2004 divided by 2 is 1002. And if you go up to 2005, it would be 1003. but we remember we're not including those. So from here to here is 1003 minus those two. So it'd be 1001. So that is a set of 1001 consecutive odd numbers. So let's see, in the answer choices, I guess this one would have to go up to 2006 in order to get that full range. If 2001 over x plus 2002 over x plus 2003 over x is 1, then x is. So if we add up the numerators, since the denominators are the same, that's 6006 over x is 1, and therefore 6006 is equal to x. And I think that's it. So that's C. What is the area of a triangle whose vertices have coordinates 1, 1, 11, 1, and 1, 11? Let's draw it. So 1, 1, 11, 1, and 1, 11 approximately. So this is sort of the triangle. This is 1, 1, 11, 11, these points on the x and y axes. So what are they asking here? Was the area? Oh, okay. Okay, well, the area from here to here, the base looks like from 1 to 11, so that's a base of 10. And the height is also from 1 to 11, so that's a base of 10 area. And this is a right triangle. So the area is 1/2 base times height. And that is 50. So the answer for number 9 is A. If the letters S, T, O, and P each represent a different positive integer, what is the least possible value of S, T, O, P if you add them together under the square root sign? So we want the least, so let's take the smallest ones. So different positive odd integers. So the smallest positive odd integer is 1. So let's take the 4 smallest. And then let's sub it in to this guy. So that would be the square root of 1 plus 3 plus 5 plus 7. And that's square root of 16, which is 4. So number 10 is B. If y is positive, then the square root of the square root of the square root of y of something is y. All right, so let's call that question mark the square root of the square root of the square root, and that's y. Is that right? I think so. Okay, so let's square both sides, and that makes this y squared. Square both sides again. That makes it y to the power 4. And let's square both sides again, and we get y to the power of 8. So that question mark is y to the power of 8, and that would be C. The least possible sum of a positive number and its reciprocal. So let's call it n, and its reciprocal is 1 over n. Least positive. Okay. So I don't know. Let's do it one at a time. The least positive number is 1. The least positive sum of the positive numbers. Number. They didn't say integer, but I'm assuming they mean integer. Okay. Positive integers. So the 1 is the smallest one. So what do we get if we put 1 here? We get 1 plus 1, which is 2. All right, let's keep going. And when n is 2, what do we get? We get 2 over 1 over 2, which is 2.5. And I think it would just become bigger and bigger. So the least possible sum is this guy here. So that would be number 12, would be C. All right, next one. X squared plus y squared all squared is x to the power 4 plus something plus y to the power 4. Okay, so let's do the expansion. And when we do, we get x to the power 4 plus 2x squared y squared plus y to the power 4. And therefore, that middle guy, it looks to me like this. And that would be, for number 13, D. There is no positive value of x less than 1 for which x to the power of 1,000 can equal. X to the power of 1,000, they're saying, okay, let's see here. There's no positive value of x less than 1 for which, let's take this one step at a time, one choice at a time. Let's see what happens here. So if that's the case, well, let's just put in a numerical value. It's, as you know, it's 3.14. So if I put pi equal to 3.14, I would get 1 over pi would be approximately 0.32 or something. So if there is no positive value, this can work, because if you take something less than 1, if x was less than 1, whatever it is, it could become a decimal. Yeah. Okay, I think I got it now. I'm finally understanding. Took me a while. X has to be less than 1. Okay, I got it. So that means, what are they saying could it not be? So it can be this, so that's fine. It could not be something greater than 1, which is this guy here, because 4 over pi is, obviously, it's greater than 1, because 3.14, 4 divided by 3.14 would be greater than 1. So you would have to have x to the 1,000 be greater than 1, and that is not possible because x is less than 1. And if you keep taking multiples, exponentially, the number would never exceed 1. Right? Try it. Take any number less than 1. So, for example, 0.9. And then just take like powers of it. 2, 0.93, and so on. And then 0.9 all the way to 1,000. This number will always just be less than 1. It will keep getting smaller, actually. So it can never be greater than 1. So that's what they're getting at, and therefore number 14 is D. Five to the power of 2003 divided by negative 5 to the power of 2002. Okay, 5 to the power of 2003 divided by negative 5 to the power of 2002. So we got 5 to the power, that doesn't change for now. Let's break this up into negative 1 and 5, and each of these goes to the power of 2002, like that. And then that negative 1 to the power of 2002 is just 1. So that means this is just 5 to the power of 2003 all over 5 to the power of 2002, and that is just 5 to the power of 1, which is 5. And therefore number 15 is B. The square of the sum of 3 consecutive integers must be divisible by. So let's make 3 consecutive integers. That would be x, x plus 1, and x plus 2. Let's divide it. Sorry, what are we doing here? The square of the sum. So we have to first do the sum and then take the square. Okay, got to read that carefully here. So this in the bracket is 3x plus 3. And then we got to square it. Okay. So if I factor out a 3, it's x plus 1. And then if I square it, it's 9x plus 1 squared. Okay, let me just double check if I did this right. X, x, and x, that's 3x. And then 1 plus 2 is 3. So that's right. And then I factor out the 3, and that would be x plus 1. And then I square it, and it becomes 9. Okay, that's correct. So what are they saying? Must be divisible by, well, 9, obviously. So that would be C. Which of the following points is not on the line y is equal to pi x plus pi? So I guess we have to substitute these guys into this. Y is equal to pi x plus pi. So let's try the first one, negative 1. When you put negative 1 as x, you would get 0 for y. Okay, so that one checks out. How about the next one? 0 and pi. When 0 is x, y is pi. Okay, that one checks out. 0, negative 1. When 0 is x, y is pi. So this one does not work. And the last one, when x is 1, you get 2 pi. So that one works. So this is the only one that does not work, and therefore it's not on that line. So C is the answer for 17. For a canned food drive, I rounded up canned corned beef and canned tomato soup. The number of cans of corned beef was 25% of the number of cans of soup. The number of cans of soup was something percent of the total number of these cans. All right, in math, that would be let C represent corned beef, and soup is represented by S, so 0.25. And then what they want us to do is figure out the number of soup cans over the total, which would be C plus S. And I think that's pretty much the mathematical setup of it. So S over C is 0.25 S plus S, so that's going to be S over 1.25 S. And then the S's cancel, and we just have 1 over 1.25, which I believe would be 4 over 5, and that's 80%. So 80% is the answer, and that would be D. X minus 1 all cubed, x plus 1 all squared is. All right, so what are we trying to do here? X minus 1 all cubed, x plus 1 all squared. Oh, we're trying to figure out what it's equivalent to. Okay, so let me just first expand this out, but I don't think I will need to do it all. Let me explain. So this and this becomes x squared minus 1. And then same thing, that and that. X squared minus 1. And this one I'll just keep as x minus 1. And then therefore I have x minus 1 and then 2 of these guys. So let's see if anything matches that. X minus 1. This one, right? A? Yeah, A is what I pretty much made it look like. So A is what it matches. X plus y minus 17 squared is 0, and x minus y minus 13 squared is 0, y is. Okay, so for the first one, x plus y minus 17 all squared is 0. If we take the square root of both sides, we get x plus y minus 17 is 0. So x plus y is 17. And in a very similar way, the second one, you take that, x minus y minus 13 is 0. If we take the square root, we get x minus y minus 13 is 0. And therefore x minus y is 13. So this guy and this one, if we add them, we will get 2x is equal to 30, because the y's disappeared, and therefore x is 15. If x is 15, we just plug that back into here. 15 plus y is 17, therefore y is equal to 2. And therefore, number 20 is A. If x minus 2 times x plus 3 is equal to x minus a times x plus b, for all real x, a, b could be. All right. 2, 3? That's the obvious one, but 2, 3 is not one of the answer choices. Okay. So let me rearrange it, I guess. X minus 2, x plus 3 is x minus a times x plus b. So the obvious one is that a is 2 and b is 3. But 2, 3 is not an answer choice. So let's see, what else could it be? If I reverse it, if I make this x, keep this the same, but then I just do this, x plus b times x minus a. Now, b is minus 2 and a is minus 3, correct? Minus 3 minus 2, that would be the AB, and that is an answer choice. That is choice D. One over x plus 1 over y is, over x plus y is. Okay, so get a common denominator, y, 1 over x plus 1 over y, and then x and x all over x plus y. So that's going to be x plus y over xy all over x plus y. Invert and multiply, and we get x plus y over xy times 1 over x plus y. Okay, the x plus y's cancel, and that leaves you with 1 over xy. And therefore, number 22 is B. Only question mark, different right angles have right lengths root A and root B, and hypotenuse of root 2003, where A and B are integers, A greater than B greater than 0. All right, whatever that means. Okay, so let's do this here. let's make a right triangle. And one side is root A, and the other side is root B, and the other side is root 2003. Okay, so we have root A all squared plus root B all squared is equal to root 2003 all squared. Okay, so that means A plus B is 2003. So we have to always abide by this rule. And keeping in mind that they have integers and that A is greater than B is greater than 0. Okay, so let's make a table here. A and B. So when A is, well, A is the biggest one, right? Okay, A is greater than this one has to be satisfied. So A is the biggest one. And they're both greater than 0. So the smallest B can be is 1, and therefore that's 2002. Yeah. And then 2 would make this 2001, and then so on down. And then eventually you're going to get to, say, 1000 and 1000 would be 1003. 1001 would be 1002. And I think that's it. After this point, the A would no longer be greater than B, so we wouldn't be able to satisfy that inequality. So that means we have a total of 1001 of these pairs. So for number 23, that would be A. When I ride my bike at a constant rate of k kilometers every h hours, it takes me some hours to ride my bike at h kilometers. Okay? So speed is equal to distance over time. So in this case, that would be k kilometers over h hours is the speed. And that is the same as distance over time. So distance for the other scenario is h kilometers over a certain number of hours. Yeah. Okay, so we got to do this here. So cross multiply, and we have k, and then the question mark is h squared. So then the question mark would be h squared over k. H squared over k. And be careful here because they look similar. That I believe is D. If p% of x is equal to 1, then 1 over p% of x is equal to. P% is p over 100 of x is equal to 1. Okay. So what do we do here? We're trying to figure out 1 over p% would be basically 1 over p over 100 is equal to, of x is equal to. And the answer choices are an x. Okay, I got it. So somehow we have to modify this to look like this somehow. And how do I do that? Well, I guess I just have to kind of fiddle around with it. Let me get this first in terms of p. So that's going to be p is equal to 100 over x. Correct? Yeah, 100 over x. So then substitute that in there. So that'd be 1 over 100 over x over 100 x. So that is 1 over 1. Oh, hold on here. 1 over 1 times x over 100. All over 100 x. Do this carefully here. So this is x over 100 times 1 over 100 x. And then therefore that would be x squared over 10,000. X squared over 10,000 is this right here. Okay, and then is that an answer choice? That is B, actually. So we got that. The product of both values of x for which 2003 to the x squared plus 2x minus 35 is 1 is equal to 2003 x squared plus 2x minus 35 is equal to 1. So if something to the power of something is 1, that means that power is 0. So this exponent is 0. So that means x squared plus 2x minus 35 is 0. Okay. So now I guess we just have to factor this and figure this out. So does it factor? X, 7, and 5. Positive, negative? Yeah. So that means x is either 5 or negative 7. And what are they saying? The product of both values. So we have to find the product. So the product, P, is 5 times negative 7, and that is negative 35. So negative 35 is the answer, and therefore that would be C. How many pairs of positive integers AC satisfy a to the power of 3 plus 125 is equal to c to the power of 3? All right. Well, okay. Well, I don't know. Let's see what we can do here. This number obviously has to be greater than this because they're both positive. So what's the perfect? That's 5 cubed, right? 125. So that means we'll start with 6 cubed and let's see what happens. If it's 6 cubed, then this would have to be 91 because 6 cubed is what, 216? So that would mean this would have to be, but 91 is not a perfect cube, so that fails. So let's try another one. Let's go to the next one, 7 cubed plus 125. 7 cubed, 7 times 7 times 7 is 343. So if you subtract 125, that would have to be 218. Correct? And 218 is not a perfect cube. So then I guess let's see what happens if I kind of fiddle around with this. If I force them to be perfect cubes, 6 cubed is equal to 7 cubed. Then what do we get here? We get 216, and I think you have to add 127, but that's 125. So you fiddle around with this, you'll figure out that there are no integer solutions. It doesn't work for anything, so it all falls apart. (28) If the reciprocals of 60, 65, and C are the lengths of the right triangle, and C is greater than 65, then C is. All right, so let's see here. Let's draw a right triangle. And you have 1 over 65, 1 over C, and 1 over 60. Correct? Because C is greater than 65. So that's, you can't put it as the hypotenuse, because the hypotenuse has to be greater, the reciprocal. So that's the only way. So if that's the case, we would get 1 over 65 squared plus 1 over C squared is equal to 1 over 60 all squared. Correct? So if we do this math, we would get 1 over 65 squared plus 1 over C squared is equal to 1 over 60 squared. 1 over C squared would be 1 over 60 squared minus 1 over 65 squared. Get a common denominator. 65 squared minus 60 squared times 60 squared times 65 squared. And that is, let's see here, 65 minus 60, 65 plus 60, 60 squared, 65 squared. And then C squared would be 5 times 125. Oops, so sorry, that's still 1 over C squared, by the way. Yeah. So this is 625 over 60 squared times 65 squared. So finally, when we take the square root of everything, you get 1 over C is equal to 65. 6 to 25 is 25, right? Like the square. So that's 60 and 65. And then finally C would be the reciprocal of that over 25. And that, I believe, is what? 156. Okay, so C is 156. And yeah, we got it. Okay, that's pretty good. It took me a while to learn how to flip flapjacks. In fact, if a plus 1 over a is 6, then the value of a squared plus 1 over a squared is the number of attempts it took me. How many attempts did it take? All right, so we obviously have to work with this guy. A plus 1 over a is 6. Okay. So, if I square both sides, because I'm trying to make it look like this guy here, somehow, I got a squared plus 2a over a plus 1 over a squared is equal to 36. So I get a squared plus 1 over a squared plus 2 is equal to 36. And therefore, a squared plus 1 over a squared is 34. Okay, so that didn't take so long. That's A. And the last one. If 3 to the power of a is 2 and 7 to the power of b is 5, what is all that? So we have 9 to the power of 4a times 49 to the power of 2b. Okay, so let's see here. We got 3 to the power of 2, because I've got to work with 3's and 7's here. That's why I'm trying to convert it. And then we have 7 to the power of 2 to 2b. So this would be 3 to the power of 8a, 7 to the power of 4b. And then if you just take out the 3a, that'll be 3 to the power of a to the 8, 7 to the power of b to the 4. So that's 2 to the power of 8, and then 5 to the power of 4. 2 to the power of 8 and 5 to the power of 4 is C.